Okay, quick revision on a chapter on sound. Okay, so what is sound? Okay, that's your definition. How is sound waves produced? Okay, the layers of air are disturbed and causes the air molecules to vibrate. So here, all these layers of air, all at rest, nothing's happening, no sound, all peaceful and quiet. Strike the tuning fork, what happens? Okay, the layers of air get disturbed, the air molecules start to get disturbed. Okay, they start to vibrate about a fixed position, parallel to the sound wave, using definition of longitudinal wave, right? So you need to know, especially for pure physics, what happens when the prongs move out. Okay, what happens when the prongs move in? Okay, so when the prongs move outwards, cause the molecules to vibrate closer together. Okay, and they wave inwards, they vibrate further apart. Okay, right, and then these are the compression areas, and the far apart is the rarefaction areas. Okay, the most important words are all found here. Okay, this part here, your own notes, please study this well. Okay, they ask you how does sound propagate, be ready to answer using all the key phrases. Okay, propagate means move, so the particles start to vibrate about fixed position parallel to direction sound wave, basically using definition of longitudinal wave. Then what happens? The molecules, they will collide to the next molecule, then they pass energy on. They are passing the sound energy along the way. And then what does this do? This creates a series of compressions and reflections, right? So that's how sound propagates. And then know the definition of compression and reflection. Regions where the air pressure is higher than surrounding air pressure, whereas this one is lower than the surrounding air pressure. Okay, so this is very useful. Okay, when they ask you explain, it comes with all kinds of questions, okay, disguises, whatever, but the answer is always the same. So you'll be using this to describe, okay, how does the sound move through air, water, or even solids, or whatever it may be. Okay, then sometimes they ask you how does the distance of the molecules vary as sound propagates. So remember the molecules, they are vibrating such that sometimes they come very close together, okay, then sometimes they go very far apart. So how do you describe the distance? You will describe it this way. Distance between adjacent molecules will increase to a maximum distance and then to a minimum distance periodically. Okay, this occurs over one period, right? Before the whole cycle repeats itself. Okay, so this is so important. Okay, I must emphasize. Not very difficult, remember. Okay, just pay attention, be ready to use it in any test or exam. Right, so next page over here, I think this should not be a problem. We don't have to go through this. Just remember, okay, compression is one wavelength, or reflection of one reflection is one wavelength. Okay, speed of sound faster in solids, you know that. Liquids, gases, you know the reason. Okay, this one normally comes out in MCQ. What's the range? 20 to 20,000 hertz. More than 20,000 hertz is known as ultrasound. Okay, so next one, experiment. Okay, how you show that sound requires a medium for transmission. As I say again, remember the diagram, that helps. And as you remember a diagram, you must also know what to describe, okay, what to say. Some people remember the diagram but then don't know what to write. So you have to talk about the four situations, okay, the three situations rather. Air present, slowly remove, totally remove, and then when air is slowly let back in. So each one, you talk about what you see, what you hear. Oh, when air is present, you see the hammer striking the bell, and sound is heard, then you keep writing. Okay, that gives you the guideline what to write. Okay, so study this, combined science, this experiment, very important. And also the shooting method, also very important. What do we use shooting method for? To find the speed of sound. So go through this. Okay, combined science especially, go and memorize this. Okay, I wouldn't worry so much about echo method, this seldom comes out. So for the shooting method, okay, go and remember to describe the experiment, and then for greater accuracy, what do you do? Minimize what? Human reaction time error. Okay, the common mistake is to write that minimize human error. Okay, remember, you're not a human error, you're God's creation. You're not a human error. So it's human reaction time error in doing what? Starting and stopping the stopwatch. Then and then the next one is swap position so that you can cancel out the direction of wind. Okay. Then of course you repeat the experiment a few times and so on. So to cut down the errors, okay, the human reaction time error especially. Okay, so know this experiment real well. Echo method, don't worry, I doubt it will come out. Okay, just remember for pure physics students, when talk about clap interval, I remind you what's clap interval. Okay, is the time taken for the sound to hit the wall and come back. So that's the clap intervals. So you make 100 claps, there will be 99 clap intervals. Okay, so look through at the examples you've done. Okay, and this calculation part of this chapter is not difficult. Okay, you're often using this formula, speed equals distance over time. And then as I told you before, when we were having our session, always ask yourself, the distance, do you times 2 or don't times 2? When do you times 2? I times 2 when I read the question and it says, hit the wall and come back. Then I put there 2D. Alright, so you always ask yourself this. Do you wanna divide the time by 2? Also can. So read, so if the sound hits the wall, okay, and then return to the point, okay, you need to put a 2D here. Okay, so be careful. Other than that, it's quite easy, the calculation. Okay, so how do you distinguish sound? Okay, there's pitch, it's related to frequency, loudness to amplitude. Okay, so usually you're asked to draw. Okay, so I will just go through one example. Okay, second wave where the loudness and pitch is decreased by half. Okay, so loudness go down by half. That means the height of the wave reduced by half. So it'll be somewhere around here, right? Then the pitch goes down by half. That means frequency go down by half. So this is the part you got to be careful. Sometimes you make mistake here because of pitch. Usually not amplitude. Pitch decreased by half. So you see, 2 waves. So if pitch go down by half, okay, instead of 2 waves, I will see 1 wave, right? So 2 waves become 1 wave. So you ask yourself, when this is 1 wave, I should now draw half a wave. Go down by half, right? So 1 wave becomes half. Then this is another 1 wave. This one goes down by another half, right? That's how you draw it. And draw it here, don't draw it continuing this way. Okay, draw it corresponding to the original wave. So that's what you get. Okay, so go and practice this. Okay, make sure you're fine, good with it. Okay, just to refresh and renew your memory on this. Okay, then you need to know the uses of ultrasound. Okay, for combined science, you just need to know what are some uses. For example, prenatal scan, quality control, okay, even to find the speed of sound. Okay, that's for combined science. You don't need to know all these details, okay? I didn't even teach you this. But for pure physics, you need to know this because they do ask you. Okay, the main thing you have to remember the property is this. Ultrasound gets reflected when it reaches what? Boundary between substances of different density. So in, let's say, a prenatal scan, okay, when ultrasound hits the area between soft tissue and bone, okay, they have different density. What happens? They'll rebound back. So when they note the time for the pulses to be reflected and the depth, they can form an image. Okay, so you need to study this. Okay, at least you know the details. You're asked to write, you can write something. Okay, rather than, oh, that's it. Okay, you will leave blank. Okay, so then quality control. Okay, same thing. So you send the ultrasound out. Okay, there's a crack here. That means there's air and there's solid. So again, there's a difference in density. Okay, the sound ultrasound gets reflected back up. Okay, so that's how it works. So do go and revise this too. And then this came out before O-level question. Okay, how do you find the speed of sound using CRO? Again, it is far more effective than using a shooting method, right? So this one you also again need to go and revise. How do you find the speed of sound, right? So basically, the idea is you send out 1 pulse, okay, it hits the wall and returns back, you get another pulse like that, okay? Then you measure you already know the distance to the wall, right? Then you measure the time here using the CRO to help you, right? And remember, you have to times the distance by 2 because it hit the wall and come back, right? Okay, so that in short is how it works, but in detail, you need to know how to write it. This is something you need to memorize, especially for O-level. It comes out, nothing to write, imagine how many marks that will cost you. Okay, so the rest of it, practice. Okay, all types of questions, whether it's graphs, calculation, explaining, look through at all the worksheets we have done. Okay, we did quite a lot of practice here. Okay, so, and then of course go and memorize the definitions. All this of sound under 10 minutes. That's great.